Let us now discuss the solution of a problem from the section Coordinate Geometry. The problem is based on the transformation of coordinates, and this question has already been made a video, and I have kept it in YouTube yesterday. Today I am doing the same problem using transformation theorem from complex numbers. And this question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the second shift. The problem is the point P with coordinates a comma b undergoes the following three transformations successively. A. Reflection about the line y is equal to x. B. Translation through 2 points along the positive direction of x-axis. C. Rotation through an angle pi by 4 about the origin in the anti-clockwise direction. If the coordinates of the final position of the point P are with coordinates minus 1 by root 2 comma 7 by root 2, then the value of 2a plus b is equal to, we are given four options. Option 1, 5. Option 2, 13. Option 3, 7. Option 4, 9. We are given a point P with coordinates a comma b, and it undergoes the following three transformations successively. The first transformation is the reflection of that point in the line y is equal to x, and the second one is the translation through 2 units along the positive x direction, and the third one is it is rotated through an angle pi by 4 in the anti-clockwise direction about the origin, and the final position of the point P is given as minus 1 by root 2 comma 7 by root 2. Then required to find 2a plus b from these given four options. Let's now as I have already told you, we will use the rotation theorem in complex numbers in this example. In the earlier video, the same question was answered using the geometric considerations and using coordinate geometry. Now we will use the rotation theorem in complex numbers to solve this problem. First of all, what is this rotation theorem in complex numbers? If P with complex number Z1, P Z1, Q Z2 and R Z3 are three complex numbers. So these are the three complex numbers there. And angle PRQ is equal to theta. Angle PRQ is theta. Then the rotation theorem in complex numbers states Z2 minus Z3, the final position, minus Z2 minus Z3 by Z1 minus Z3. Z2 minus Z3 by Z1 minus Z3 is equal to modulus of Z2 minus Z3 by Z1 minus Z3 into e to the power of I theta, that is the angle theta. Now we have the corollary. If R is the origin, then what happens? So now, the R has become the origin now. Then wherever there is Z3, substitute 0. You will get Z2 by Z1 is equal to mod of Z2 by Z1 into e to the power of I theta. Now, we make another corollary. If OP is rotated through an angle theta about the origin, it is rotated like this in the anti-clockwise direction through an angle theta, then when it is rotated, OP will be equal to OQ, that is the modulus of Z1 is equal to modulus of Z2. And this will be like this, that is OP is equal to OQ because of the rotation, and Z2 by Z1 is equal to modulus of Z2 by Z1 into e to the power of I theta. Now, mod of Z1 is equal to mod of Z2, therefore this will be 1. So, Z2 is equal to Z1 into e to the power of I theta. So, if Z1 is the affix of a point P as a complex number Z1 and it is rotated, OP is rotated through an angle theta to get OQ, then the affix of Q is Z2. Then it says Z1 is transformed to Z2. Z2 is the final and Z1 is the initial one. And so that is the formula what we are going to use. Let's now discuss the solution of the problem in detail. Given that the point P with coordinates a comma b undergoes the following three transformations successively. First one, reflection about the line y is equal to x, then P a comma b becomes P b comma a, that is the x coordinate, the abscissa becomes ordinate and ordinate becomes the abscissa, and that is P a comma b is transformed to Q b comma a by this one. And second one, translation through two units along the positive direction of the x-axis. So b comma a will be shifted to b plus 2 comma a because there is a translation through two units in the positive direction of x-axis and the ordinate remains the same. So b comma a will go to b plus 2 comma a. Now rotation through angle pi by 4 about the origin in the anti-clockwise direction, we will use the rotation theorem from complex numbers, and that is the final one, that is the transformed one is Z2 is equal to the given one is Z1 into to the power of I theta, where theta is equal to pi by 4, and Z1 is this point b plus 2 comma a is to be looked upon as a complex number as b plus 2 plus ai, and you know x comma y is recognized as the ordered pair x comma y is recognized as x plus iy. So what we do is the Z1, that is the given point b plus 2 plus ai in complex notation, and that will be transformed to Z2, that is b plus 2 into plus ai, b plus 2 plus ai multiplied by e to the power of I theta, where theta is equal to pi by 4 using the rotation theorem. So, and it is given that the final position is the ordered pair minus 1 by root 2 comma 7 by root 2. This as a complex number is minus 1 by root 2 plus 7 by root 2 I. So that is b plus 2 plus ai into e to the power of I pi by 4 is the final one, and that is equal to minus 1 by root 2 plus 7 by root 2 I. Yes. Now, from this you have to calculate 2a plus the value of 2a plus b. That we will do in the next slide. We have, this is the one what is brought forward from the previous slide, and that is we are required to find 2a plus b, yes, and b plus 2 plus ai multiplied by e to the power of I pi by 4 is cos pi by 4 plus I sin pi by 4 is equal to minus 1 by root 2 plus 7 by root 2 I. and cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2, and then this will be the. Now multiply. If you multiply b plus 2 into 1 by root 2 plus ai into I 1 by root 2, that is minus a by root 2. That is the real part. The real part, and similarly the complex part is this one. The imaginary part is this one. This is the real part. After multiplication is the imaginary part is equal to the minus 1 by root 2 plus 7 by root 2i. These are the two complex numbers. Two complex numbers are equal if and only if their real parts, their corresponding real parts and imaginary parts are equal. Equating the real and imaginary parts on both sides, b plus 2 minus a by root 2 is minus 1 by root 2. b plus 2 plus a by root 2 is equal to 7 by root 2. Root 2 cancels, and you will get b plus 2 minus a is equal to minus 1, b plus 2 plus a is equal to 7. From this you will get b minus a is equal to minus 3, and b plus a is equal to 5. On solving, we get a is equal to 4 and b is equal to 1. Therefore, 2a plus b value will be 2 into 4 plus 1, that is 9. Let's look at our options. Our answer 9 appears against the option 4. Therefore, our final answer is option 4. That is the discussion of the solution of the problem using the rotation theorem from complex numbers. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.